Welcome everybody to our next Fibre Live series session brought to you by International Fibre. My name is Paul Joseph and I'm the editor of International Fibre magazine. And today we have an exclusive presentation session brought to you by Felix Heck, Sales Manager of APSensing. Felix will be talking to us today about linear heat detection and its applications. Over to you, Felix.
Okay, thank you very much for the introduction. So my name is Felix Heck from APSensing, and I'm going to present our N45 series of the fiber optic linear heat detection system. At first I will introduce the company, APSensing, then continue with my favorite topic, the applications. And then we talk a little bit about the technology of fiber optic linear heat detection systems and continue with the planning and measuring concept. And then it's time for questions. And of course, if I can answer, also for the answers. Yeah, APSensing. AP stands for advanced. Advanced means modern, innovative, and futuristic, according to the definition. And photonics is a part of the physics, the optical part of the physics. It's the generation, the detection, the manipulation of light. And with this, we can process signals, we can modulate and emission light, or we can measure the movement of photons. And that is exactly what we are doing. We are sensing with light. APSensing has a company background history with Hewlett and Packard. So in 1939, here in the front of the garage in Palo Alto, Mr. Hewlett and Mr. Packard started a test and measurement company. And they established the first production site outside the US in Böblingen. This is very close to our head office, to our headquarter at the moment in Böblingen. In 1959, and they spun off the measurement business to Agilent Technologies, and Agilent Technologies then continued with the measurement business until 2007, and then decided to also to spin this off. And in 2007, our current management bought APSensing and formed and founded APSensing, and until today we are in business and we are doing good with what we are doing. We have as you can see, we have a long history, and I'm very sure that we will also have a bright future. Yeah, this map shows the world of APSensing. We have a lot of subsidiaries around the world. Subsidiaries means that they are almost independent from the headquarter. So we have salespeople there, and we have technical support teams there all around the world, and we can handle projects, or they can handle projects themselves once they got the order from the customers. Audits and certifications is a very important topic, especially in the fire protection world. So for the company, we have a lot of ISO standards. I want to mention especially the ISO standard 20007 So this is the information and security management system. And this certificate is very important for the cybersecurity and IT security, as we are also working on critical infrastructures. And of course, we have the usual fire approvals from the German VDS, according to the N45 Of course, for the European norm, we have the UL listed certificate 521 for the UL market. X approvals for the dust and gas zones 0 and 20. So it's the most critical explosive environment. FM approval, the industrial seal approval, and also the X approval IECX, of course. Yeah, let's talk about my favorite topic, the applications. Usually I get questions from customers. Okay, Felix, we have a super special project. Can you help us with this? And yeah, super special projects is our daily business, as you can see here. So the fiber optic linear heat detection system is well known for traffic tunnels and road tunnels and rail tunnels and so on. But there's a lot of there are a lot of more applications that we where we can install our fiber optic linear heat detection systems in. For example, in food production, in parking garages, where we protect the parking garage itself, but also the charging infrastructure for the e-vehicles. Utility tunnels with cable trays in there, or long pipes also under large industrial production lines, for example. In the past years, photovoltaic installations is really a big business for our systems, where we protect very large installations on rooftop, for example, production or warehouses, large halls, or also in the greenfield, where we protect large installations, PV installations. Oil and gas, for example, here on the right side below. This is also one of our applications where we install our systems. Conveyor belts, this is a long list of applications. Yes, conveyor belts, for example, production areas and so on, food processing. This is really something where we are at home. I just want to show some pictures of our installations here. We have, for example, protected a solar plant in Abu Dhabi, all around the world. So we are an international company, as I said. So all around the world, we protected installations. And here in Abu Dhabi, we protect not only the panels for photovoltaic installations, it's also important to protect the cable trays, because this is very important, because there is the packing of cables and the current heat, the heat from the current, and also connection plugs and so on that can fail. And this is important to protect the cable trays as well. Yeah, conveyor belts, as I mentioned here, for example, a coal mine in South Africa. Here you can see the sensor cable along the conveyor belt. We can also run the sensor cable in zigzag to measure the heat of each and every roller or idler, and therefore provide information to the operators about doing predictive maintenance, for example. And this is a coal mine. Of course, here it is also important to have the X approvals. From very dirty, dusty coal mines in South Africa to German food industry. Here, for example, it is not the dust and the dirt, it is more the cleaning process that is really a challenge for this environment. We have a very, very high humidity, sometimes with chemicals and so on, different temperature zones. So in the production is a different temperature than in the cooking area or in the deep freeze area. So this is something that we have to deal with in terms of fire protection, and our linear heat detection systems can really be a very good solution here. Floating roof tanks in the United Arab Emirates. Here we have large, very large floating roof tanks. We protect the outer rim here of the seal of the floating roof, but also the walls here. And you can see the tanks here in the front. And all these tanks can be protected with one, depending on the requirement of the customer, with one or two controllers, fairly easy, and exactly locate the heat source and where the fire is located and so on. Yeah, all around the world, coming to Doha, to Qatar. Here we protect, for example, this electrical installation, a utility tunnel, We can protect either each and every cable length or some connections inside the cable tunnel or the cable tunnel in total. If a fire will break out, we can send the fire brigade directly to this position. And this is something that is very important if there's smoke distributed and the fire brigade cannot see anything in such a tunnel. This is very dangerous for them. Parking garages, back to Europe, to the airport in Schiphol in the Netherlands. For example, parking garages is an important business for us, where we can protect, of course, the parking garage if a car is burning, no matter if it is an electrical or a combustion car. But we can also detect the heat increase inside the charging infrastructure. So if there's a heat increase somewhere in the charging infrastructure, we can give the operators of the parking garage a signal and an information, and they will then be able to deal with the situation at an early stage. They must not wait for a fire. Yeah, some time to talk about the fiber optic linear heat detection system. First, a little introduction so that you can, that you are aligned with technology. So the official name is a non-integrative resettable line type heat detector for our friends from the specifications and so on. It is a special detector of a fire system, an approved detector of a fire system, and the relevant approvals, of course, are the EN5422, UL for Europe, UL 521, and FM for the American, for America's continent, let's say. The fire pattern, the temperature we are measuring can be convected. For example, convected heat is rising heat because of the heat itself. A burning car in a tunnel or in a parking garage, the heat will rise to the ceiling, and this is convected heat. We can measure also radiated heat. For example, as I mentioned, the conveyor belt. Yeah, we cannot touch the conveyor, or the movement of the conveyor will blow away the heat from the roller itself. So we measure radiated heat on a conveyor or on a machine. And we can also measure conducted heat. That means, for example, on cable trays, we put the sensor cable directly on the cable tray and measure the temperature of the cable itself. Same with, for example, battery power stations or so. There we measure heat by conduction. How do we measure this? We have a sensor cable. Unfortunately, the sensor cables can be very long with our systems, up to 16 kilometers per channel. And we can have up to 4 channels on our devices. So very long, very flexible opportunities to do a measurement concept. The sensor cable itself is super light and flexible. It's a 4 millimeter cable. Both cables are 4 millimeter cables with a 4 millimeter diameter. Mechanically, absolutely robust. It's absolutely passive. We are measuring with a light. That means that electromagnetic disturbances will not have an influence in our systems. So railroad tunnels or so, and also underground subway tunnels or so will not have an effect on our measurement system. The sensor cable itself has a very long lifetime of 30 years. The sensor cable itself is maintenance free. Yeah, you cannot open it, you cannot look at it. It doesn't make sense. From time to time, you have to have a look if the sensor cable is still in position, and then everything is fine. Functional integrity of 2 hours at 750 degrees. That means that we can measure throughout the whole fire incident, and provide the data to the investigation police also for the investigation later on. precise location. I measured this already up to 0.5 meter spatial resolution, where we can tell the operators, okay, as exactly the position where the temperature is located and what is the value of the temperature itself and the propagation of the fire. So if there's one car burning or two cars burning and so on and so on. Very important for the fire brigade. And last but not least, we provide customized lengths for the sensor cable. So if you need 1,350 meters, for example, then you will get this from us, also with pigtails on both ends. So very practical and very convenient for the installation company. The sensor cable must be connected, of course, to our controller, as you can see here, and the controller will send out a laser pulse into the fiber, and by the scattering of the molecules, let's say, on a certain position along the whole sensor cable, yeah, we measure the temperatures along the whole sensor cable, and if at a certain position the temperature is too high, yeah, then passes a certain pre-adjusted temperature, then an alarm will be triggered. We will see this later on. An alarm will be triggered, and then the linear heat detector will trigger the alarm for the fire panel and then issue a fire alarm. In this slide, we see the temperature curve of a 2 kilometer long sensor cable here, and this is the red one is the temperature curve. The sensor cable is 2 kilometers long, and it's not very practical to have one signal from a 2 kilometer long sensor. Yeah, please run the 2 kilometers to search for the fire. So we separate the sensor cable in zones. Here, for example, zone 1, I show this here in the slide, can be directly connected to the second zone, for example. Yeah, so there's zone 1 and the zone 2 has a different length in this case. We can have partially overlapped zones, for example, for escape routes in a tunnel also. There, the escape route is here in the middle, and zone 3 and 4 are partially overlapped. We can also have completely overlapping zones. Yeah, for example, if you want to create a pre-alarm and a main alarm, this can be done by completely overlapping zones. Zone 5, for example, is more sensitive and informed, for example, the facility manager. And zone 6, then, if this alarm will come out, then the fire brigade will be called. And if at a certain position, for example here, the heat increases, the heat increase will be measured, the alarm characteristic at this position will be exceeded, we will trigger an alarm. And if an alarm will be triggered here, then, for example, one of our 98 relays in the controller will then be triggered, and this will then show the exact position for the fire brigade to go there and extinguish and deal with the fire. There are also zones without, there are also parts of the sensor cable without zones. Here it can burn, the sensor cable will see it, the sensor will measure it, but we will not trigger an alarm. This can be, for example, between two buildings or so, connections between two buildings. Yeah, the zones, each and every zone, we can have up to 2,000 zones along the sensor cable per channel. Yeah, 2,000 zones per channel. And each and every zone can have up to 5 different alarm parameter sets or alarm parameters. This is the maximum temperature alarm, for example, as an example, at 60 degrees Celsius, the fire brigade will be called. Then we have 3 rate of rise criteria. If the temperature will rise within a certain time, then the fire brigade will be called. Can be for slow smoldering fires or for very fast fires. Yeah, for example, within 2 minutes, the temperature will rise about 14 degrees Celsius. Then the fire brigade will be called. And we also have the zone to difference, difference to average zone alarm. If within a zone, the temperature will rise to a certain value, 10 degrees, 15, 20, depends on the adjustment, then also the fire brigade will be called. Yeah, let's speak a little bit about the system itself, about the controller, as you can see here. So we provide different housings. This is important for the flexibility of your project. The standard housing is the 19-inch to height unit housing that can be integrated into the cabinet with a fire panel. But we also provide a wall mount housing, can be easily installed directly on the wall in the technical area somewhere. And if it is not possible, or if you do not have a technical area, then we can also install an IP66 cabinet somewhere in the field, wherever it is necessary, very close to the conveyor, or somewhere else in the production, for example. Yeah. On the front, as you can see here, we have a color display, TFT display with all the information that you might need during the operation that will be provided here. Alarm, faults, measuring status for of the controller. And also that is that is a very good feature that we integrated here. Also, the installers can program their address and their information here in this screen. And if there's a annual maintenance coming up, the display will then show, please contact company XY to do the maintenance, the annual maintenance. Backside of the controller, I want to not to go into every detail here, but to summarize, of course, we have interfaces with Modbus, TCP/IP. We can provide information here through the line ports. We have the relays here. We have the 10 standard relays, but we can provide extensions, 44 or 88 relays. So in total, 98 relays are possible at the backside of the controller. We have the sensor channels here on the right side. We have controllers with just one sensor channel, with 2 sensor channels, or here fully equipped with 4 sensor channels. Talking about the commissioning of the device, also here our research and development department put a lot of thoughts in it, and how the usability, to increase the usability of the system. So the software is on the controller itself. You just connect your laptop to the controller, call the software up, and then you can use and program the device. So no extra software is needed, no extra laptop for an extra guy or something. All the software for the commissioning is on the controller, is super user-friendly. We also have integrated some feature into this software. For example, the auto setup. So you install the system, you just press the button auto setup, and the controller will measure the sensor channels and the connected fiber length, and start the initial measurement. So the controller is then working. We have then the calibration wizard, for example, with the intuitive and very simple drag and drop calibration of the temperature that is measured, or if there are some splices along the fiber or so, it's easy to drag and drop the temperature lines, and balance the temperature there. Certification Wizard is also on board of this the commissioning software, where we check the sensor cable and adjust the parameters of the EN and UL settings, for example. This is a very practical approach to install and adjust the system in the correct way. Further to this, we have for the documentation the system report, and also if there's help needed or if we should finally check the adjustments of the sensor, then we can use the support data function, and our support system or team can then help with the right adjustments of the controller. Last but not least, usually we have the fire panel, the fire alarm and control panel in the fire system world, but we can also provide the visualization software here. Here, just some screens that you get a feeling how such a visualization can take place, and if there is an alarm here, this is here simulated on this solar panel. If there's an alarm, for example, and a window pops up and tell the operator directly what to do and where to go and how to deal with this problem. Planning and installation, for various applications, of course, as I have shown, there are different opportunities for the use of LHD and the installation of the sensor cable and so on. Here, a general approach and the most important topics that come up when you start with a project, it's the measuring concept. So this is something that must be decided and discussed very much in advance. So we have here, for example, highway tunnel. This is the application we mainly have, highway tunnel, and we want to protect this highway tunnel with a single-ended measurement. That means that we have the controller in the control room, and we have one fiber connected to the controller, and we measure from the controller until the end of the sensor cable, and that's it. If there is an interruption here, the rest of the sensor cable is not protected anymore, so this is something that has to be considered. And this is a very rare measuring concept. We usually have the following one with two channels on the controller, and the sensor cable will then be looped throughout the highway tunnel here. So the fiber optic, the fiber optic fiber will then be connected to both channels in the controller, and the controller then measures with the first channel, for example, here, this way around through the highway tunnel, and then from the second channel backwards to the first channel connection here. If there's an interruption, the controller will take out approximately 20 meters from the cut, and then measure from both sides up to the cut, and this controller will signal system fault or sensor cable fault, and this can be fixed then by just splicing the sensor cable, and then the controller will go back in operation. Another solution could be with two controllers that measure from both sides into different fibers. Here we always have two fibers in the sensor cable. So with the first controller, we measure into the red sensor cable throughout the whole installation, and the red sensor cable will be terminated at the end. And then with the green fiber, we measure with the second controller backwards to the controller number one, and it's a full redundant setup that will be used, for example, in Swiss road tunnels, and if there's a certain need for protection. That's it for the moment. from me. Here you have my contact information. If there are any further information you need, please do not hesitate to contact me, and we can continue with the questions.
Well, thank you so much for a great presentation, Felix. We do have a couple of questions that will hopefully provide slightly more detail on some of the areas that you touched upon, if that's okay with you.
Yeah, okay. Go ahead.
So the first one is about your sales strategy and new market segments at APSensing. Are there any new industries, vertical markets, or applications that APSensing are approaching with the linear heat detection systems?
Yeah, sure. We are after the focus on solar installations, on PV installations, and so on. We are now, in the past 2 years, let's say, we are now focusing on the maritime business. So we got the maritime approval from the DNV, Det Norske Veritas, and we can install our systems now on any maritime vessel or environment, let's say, infrastructure. And we are now approaching the maritime market and install, for example, our systems on board of vessels, ships, ferry boats, container ships, and also converter stations. And approach the maritime market now.
Our next one is about customers and customer structures internationally. Are you selling directly to end customers or distributors? How does it work exactly?
Okay. Here in Europe, we established a customer network, let's say, of specialized companies, specialized companies for a certain region or a certain country. That are dedicated to special fire detection, but we are also working with global fire companies, well-known brand names in the fire market. Yeah, and that these companies then integrate our special detector in their complete fire system, and then use it as a fire detector for their fire panel.
Got it. Thank you. Our final question to wrap things up is about technical measures for the maintenance of the LHD system. What is the scope of maintenance and service work on an LHD?
Mm-hmm. Yeah, first of all, I have to say that the national and regional regulations must be considered with when it comes to maintenance and service works. The maintenance duties that are usually necessary for our systems are very few. You just have to check if the sensor cable is still in position, and then trigger one alarm, and then that's pretty much it. You trigger the alarm and check the zoning, if the zones will be transmitted to the fire panel, and that's pretty much it.
Well, thank you so much again, Felix, for your time and obviously your insightful presentation. If anybody would like to find out more about APSensing, you can see that there'll be a link in the live discussion box. It will come up now and you can visit the website directly. It's been a pleasure having you as part of our Fibre live series, Felix. Thank you so much.
Yeah, thank you very much, and thanks to the audience.